Good morning, students. Today we are going to discuss about laws of equivalence. So the previous class we have seen the two compound statements or how they are logically equivalent. So based on the equivalence we are going to see 9 laws. The first law is Idempotent Law, that is P or P, that is logically equivalent to P. P and P is logically equivalent to P. So see the truth table. Here only one statement P. So P is true. And here also the same P is taken here. So that is truth value is true and true. So P or P. So R means any one is true, it is true. Both are true also, it is true. So true true varum. False you are having false. P and P means both are true only, it is true, otherwise it is false. So true it is true and false it is false. You look at that P or P and P. Okay, P and P, how they are identical. So therefore P or P is logically equivalent to P and P and P also is logically equivalent to P. So it is called the idempotent law. In exams they can ask state and prove the idempotent laws. So you have to write the statement and you have to give the truth table for the proof. And second one we are going to commutative laws. So you know very well the first one, P or Q is logically equivalent to Q or P. And the second one, if you use AND connective, P and Q is logically equivalent to Q and P. Okay, so see the tabular column, the proof. So here PQ, two simple statements are used. So we have to write how many rows? 4 rows has to be written, having the entries true, false, false, true, false. Okay, P or Q. R means what? Any one is true, it is true, or both are true also, it is true. So here both are true, so it is true. Here P is true, so this is true. And here Q is true. One is true, so it is true. Here both are false, so it is false. So here next one, what you have to find? Q or P. So if you interchange Q or P, so you take Q or P means any one is true, it is true. Both are true also, it is true. So it will come here as true. Here this is true, so it is true. Here Q is true, so Q or P is true, and here both are false, it is false. So therefore you look at this third column and the fourth column, they are identical. So P or Q is logically equivalent to Q or P. In the same way you can go for the proof of P and Q and Q and P. P and Q is what? And means both are true only, it is true. So first row alone true, so here it is true. The others are false. In the same way Q and P also the same thing has to come. So these two columns are identical. So therefore P and Q is logically equivalent to Q and P. So there's two statements. If you have and or, here you have or, here you are having and. So we can logically they are equivalent to Q or P and Q and P. So that is called the commutative laws. Next we are moving to the associative laws. For that we have to take three statements P, Q, R. You look at the symbol P, R, Q, R. See that if the first one is R means in the bracket also the same connective is used. Okay, so it can be associated P or Q or R. In the same way if you use and, you see that here also and in the bracket the connective also and. You see that same connectives are used, we can associate P and Q and R, that is equal to P and Q and R. So see that three statements, so 8 columns I have written. Under P column 4 T and 4 false is written. Under Q 2 T and 2 false is written, and R 1 true 1 false. It is alternatively written up to 8 rows. So here the first one bracket term Q or R. So Q or R. So you have to see the second and the third column. R has to be used. R means if any one is true, it is true. So you will get here both are true. Any one is true, it is true. And both are true also, it is true. So therefore the first one is true. Second one also true. Here the third one also true. You look at the fourth one, both are false. So it is false. Here both are true, so it is true. Here one is true, so it is true. Here R is true, so it is true. So here both are false, so it is false. So you see now P R Q R R. So Q R R in the fourth column, P is in the first column. So you have to see which one. First and the fourth column. First and the fourth column. In between what you are having R. So you look at the first and the fourth column. You should not see the second one. First and the fourth column you have to see. You see now here. You see the first column P is true and this also true. Both are true, so it is true. And here next one also both are true, it is true. And next also both are true, it is true. But in the fourth row, one is true, P alone is true, so it is also true. And here in the fifth row, you see Q R R is true. One is true, so it is true. Here on the sixth row also one is true, it is true. And coming to the seventh row, it is Q R R. That one is true, so it is true. And here the next one F F. So here also F, here also F. Both are F, so it is F. Okay. In the same way, you come into this side P R Q. So P R Q means what you have to see first and the second column. R means any one is true, it is true. Both are true also, it is true. So here both are true, so it is true. Here also both are true, it is true. So here one is true, so the third row here you are having true. Here also P is true, so one is true, so it is true. Here also one is true, it is true. So here also in this row also one is true, so therefore P R Q is true. Here both are false, so it is false. Here also both are false, it is false. Okay, so which one you have to see now? P R Q or R. So P R Q is in this column, so this column, and R is in the third column. So you have to see which one. Third and the sixth column. Third and the sixth column. You see my hands. So these two you have to concentrate. You should not concentrate the remaining. So here what you are having R. So R means what? Both are true, so it is true. Here one is true, it is true. Here both are true, it is true. Here one is true, this is true, so it is true. Here both are true, it is true. Here one is true, this one is true, so it is true. And here this one is true, so here R is true here, so therefore it is true. And here you look at this, both are F, so it is F. Okay, so you have to, which one we have to see? They are equivalent. These two are equivalent. This is in which column? So the fifth column. And this result, this compound statement is in the seventh column. You look at that, how they are. Everything is true except the last one. So therefore the columns corresponding to this and this are identical. So therefore the compound statement are logically equivalent. This is nothing but the associative law. Associative law, when you use the connective before the bracket and after the bracket, inside the bracket they are same. P or Q or R is logically equivalent to P or Q or R. Okay, in the same way we are going to use and. The same thing we are going to using the connective and that also called associative law. You see that P and Q and R is logically equivalent to P and Q and R. So PQR, the result is written here in the bracket term is Q and R. Q and R means second, third column you have to concentrate, second and the third column. Okay, Q and R means what you have to do? And means both are true only, it is true, otherwise it is false. You look at the first two, here both are true, so it is true. Here one is true, so it is false, because here it is and is used. Here also false. Here both are false, so it is false. Here both are true, so it is true. And here it is false. Here one is true, so it is false. Here both are false, so it is false. Next, P and Q and R. So Q and R is in the fourth column. P is in the first column. You look at that. Both are true, so it is true. And here one is true, so it is false. And here also both are, one is true, so it is false. Here also one is true, it is false. Here one is true, it is false. So here also both are false, it is false. Here both are false, it is false. So both are false, it is false. So we have found the left side. And coming to the right side, what is needed? P and Q. So P is in the first column and Q is in the second column. Here you have to use and. And means both are true, only it is true. So therefore you look at this. Here both are true, so it is true. Here also both are true, it is true. You look at that. Here one is true, so it is false. Here one is true, it is false. Here also one is true, so it is false. Here also the same thing, one is true, so it is false. Here both are false, so it is false. So and means both are true, only it is true. Next it has to combine with the R. So R is in the third column and this is in the sixth column. You look at this, R and P and Q. So R, both are true, so it is true. Here one is true, so it is false. Here also one is true, so it is false. Here both are false, it is false. So here one is true, it is false. Here both are false, so it is false. And here one is true, it is false. And here both are false. So you have to see the fingers. So false, false, so it is false. So you have to see the fifth column and the seventh column. You see the truth values. Only one is true, others are false. They are identical. So therefore P and Q and R is logically equivalent to P and Q and R. So this is called the associative law. So we have seen how many laws? 3 laws. One is the idempotent law, next one is the commutative law, and the third one is the associative law. Coming to the fourth one, distributive law. You look at that. Here in front of the bracket you are having R, but inside the bracket you are having and. You see the connective, there is a change. If the connectives are same, you have to use the associative law. If the connectives are same, you have to use the associative law. If the connectives are different, you have to use the distributive law. So P or Q and P or R. Okay, here the connectives is changed. So here it is and, here it is R. So P and Q or P and R. Okay, so for the truth column, you see now, here the first one, P, Q, R is written. First one is what? Q and R. So second column and third column, you have to use that and. And means both are true, only it is true. So it is written like that. It is this P or Q and R. So P is in the first column and this is in the third column. In between you have to use R. R means what? Any one is true, it is true. And both are true also, it is true. So in this way it is filled. Next coming to here, P or Q. R means what? P and Q. P and Q is first and the second column. You have to use the connective R. R means any one is true, it is true, and both are true also, it is true. So therefore you will have here P or R. So P is in the first column, R is in the third column. So the first column, second column, you have to use the connective R. R again what it is? Both are true, it is true. One is true, any one is true, it is true. So using this, this one is found. And in between you have to write and. Which one? Which column? This column and this. P R Q and P R R. In between you have to use and. And means both are true, only it is true. So see now, both are true, so it is true. Here also in the up to this row, both are true, so it is true. Here one is true, so it is false. Here also one is true, it is false. Both are false, also false. You look at that. This one, this column, and here the last column. You see the truth values, they are identical. So therefore P or Q and R. You look at this. The connectives are changed here. If it's so, you have to use distributive. So P or Q and P or R. So the first one we have proved distributive law. We'll go for the second one. The same way you have to prove. So first one, what you have to write? You have to write P, Q, R. So 8 rows has to be written. So here in the bracket, first you have to evaluate Q, R, R. Next P and Q, R, R. Next P and Q, that has to be found. Next P and R. So for these two you have to use the connective R. Okay, so here the same thing. R means this is the symbol, isn't it? So both are true, it is true. If any one is true, it is also true. But while you are coming and both are true only, it is true. Otherwise, it is false. So while you are seeing this, you have to see the P column, that is the first column, and Q or R column. So that is the fourth column. Only you have to concentrate the first and the fourth column, and you have to use the connective and. So and means both are true only, it is true. So in this way, if you fill up, you see this column and the last column, how they are. They are, what is it? Identical. They are having the same truth value, so they are identical. So therefore, they are logically equivalent. So it is called the distributive law. Okay. So the next one, we are going to the identity laws. Okay. You see now, P or T. R means what I have said. If any one is true, it is true. So here you are having true. So it is true. So P R T, it is equal to T. Okay. Any statement, the connective R you used with the T, only true. That is logically equivalent to T. Because R, if it comes, the connective R comes, any one is true, it is true. So here one is true, this side is true. But here if it is true, that also true. P is true, that also true. You see that P is true. P is true and true, so it is true. Okay, P is false means false true, also false, because one is true means it is true. And come to F. F is false here. F false means you have to get any one is true. So if P is true only, it is true. If P is false means it is false. So therefore it depends on P. So therefore P or F is identically equal to P. You look at this P or F. What is P? This is F is FF. True. First one, P is true and here it is false means it is true. Okay, here both are false means it is false. So this is equivalent to which column? P column. So therefore P or F is logically equivalent to P. Okay, so R means any one is true, it is true. So here you are having only one true, so it is true. If false comes, it depends on P. If P is T means it is T. If P is false means it is false. So therefore it is P. And coming to and means you have to check both. Both are true, only it is true. Okay. See now here, if P is true, so P is true, this is true. If P is false, it is also false. This TF is logically equivalent to P. So therefore P and T is logically equivalent to P. P and F, you see that F comes and means what? Both are true, only it is true. Here you are having only one F, so therefore it is false. So therefore P and F is logically equivalent to F. This is called the identity laws. Okay, so the truth table is here. And look at this, P and T, it is equivalent to T. And P and F, TF, it is identical to P. And P and T is identical to P. TF, here also TF. So P and T is identical to P. P and F, only FF. So therefore it is identical to F. Okay. And complement laws. So see that complement, P or complement of, that is P or negation P. So see that any one is true, it is true. So here P or negation P is true. Okay. P and negation P is equivalent to false. P or comes the statement with its negation. If you have or connective, it is true. You look at this, P is here, its negation means false T. Okay. R use பண்ணும்போது any one is true, it is true. So therefore both are true. So R comes, the statement and it is negative, is logically equivalent to T. And comes means it is logically equivalent to false. This is one kind of complement statement. Another one you know very well. Negation of T is false and negation of false is T. Okay, these two are complement laws. The next one is a involvation law or a double negation law. So it is negation of negation P is equivalent to P. So P is here, negation P. Idukku negation. So what you have to do? If negation means you have to write the opposite. If P, this is false means here you have to write true. This is true means it is false. This is equivalent to. These two are identical. Which two are identical? P and negation of negation P are identical. So therefore negation of negation P is equal to P. That is the involvation law or double negation law. And the eighth one, we are moving to the De Morgan's law. So you have studied De Morgan's law in the set A union B the whole dash is equal to A dash intersection B dash. Okay, in the same way, negation of P and Q. You see that negation of P and Q. Here and connective is used. How it is equivalent to? It is equivalent to negation P or negation Q. Okay, here and is used. Here you are having R. In the same way, negation of P or Q can be written as negation P and negation Q. Okay, you see the truth table for the proof. First one, PQ, only two statements. Here P and Q, so negation of P and Q. In the same way, the next one, PRQ, negation of PRQ. So if it is asked means you can write the what is the truth table separately according to what is asked. State and prove De Morgan's law means you can write both the statements and you can write it in the same tabular column. So it is written, and here for this negation P, negation Q, for the first statement I have written, what is it? It is negation P or negation Q, negation P and negation Q. Okay, so see now here. So what is it? Here P and Q. So and you know that very well how to write. Both are true only it is true, otherwise it is false. Negation of this one. So here you are having true, so its negation is false. If all are false, so all the places you have to write true for its negation. P, R, Q. R means any one is true, it is true. So here both are true, it is true. Any one is true, so it is true. Here both are false, it is false. So negation of P, R, Q means if it is true, here it is false. So false, false, true. Next one, negation P, you know very well. So P column whose negation has to be written. In the same way, negation Q. Now we have to see negation P, negation Q. In between you are having R. R means any one is true, it is true. Here both are false, so it is false. Here one is true, so it is true. Here one is true, here it is true. Both are true, so it is true. And while you are coming, you have to see negation P, negation Q. Both the columns you have to apply the connective and. So and means both are true only it is true. So the first one is false. Here also the second one also false. The third one also false. Here only both are true, so it is true. Okay. So see that. If what columns are identical, you look at this. Here only one F, the remaining are 3T. So here only one F, the remaining are 3T. So therefore negation of P and Q is logically equivalent to negation P or negation Q. And you see the next one, F, 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 T. First three are F and the next one is T. So here you are having 3F and T. So therefore negation of P or Q is logically equivalent to negation P and negation Q. So therefore the De Morgan's law, negation of P and Q is logically equivalent to negation P or negation Q, and negation of P or Q is logically equivalent to negation P and negation Q. So it is the eighth law. The next one we are moving to the absorption laws. So what is an absorption law? So that is P or P and Q. P or P and Q. You see that? Here, associative law, distributive laws, we will use three statements, P, Q, R. But here you see that P, R, P and Q. So here R comes. So R comes, it is logically equivalent to P. Mary P and PRQ is logically equivalent to P. So that is called the absorption law. So PQ, the two statement, here P and Q. And means what? Both are true only, it is true. So other things are false. So P or P and Q. So first column and the third column R. So both are true, it is true. So here it is true. Here one is true, so it is true. Here both are false, it is false. Here also both are false, it is false. So this column and the P column, they are identical. So therefore P, R, P and Q is logically equivalent to P. The same way, you just find out P, R, Q. R means what? Any one is true, it is true. Both are true also, it is true. So both are true, it is true. One is true, so it is true. So here you are having false. So this column and the first column, you have to use the connective and. You have to use the connective and. See here T, here T. Both are T, so it is T. And here both are T, so it is T. And here only one T, you are using the connective and both are T only, it is T. So here it is false. Here also false. Okay. So you look at this last column and the first column. How they are? They are identical. So therefore P and PRQ is logically equivalent to P. So we have learned the laws. Using the equivalence property, we have to prove some compound statement. So see that exercise 12.2, exercise 12.2, 12th problem. Check whether the statement P implies Q implies P is a tautology or a contradiction without using the truth table. So you should not use the truth table. Without using that, we have to prove. So here we have laws. So 9 laws we have learned. Using the law only we have to prove. So before that, you should know this. P implies Q is logically equivalent to negation P or Q. So here the first statement is P, the second statement is Q. So P implies Q. If P, then Q is logically equivalent to negation P. So the first statement you have to write negation, then or the second statement. So P implies Q means negation of first statement or the second statement. Okay, you take this statement, the given statement. What is it? P implies Q implies P. So this is the first one and this is the second one. So the whole thing is the second one. So using this property, using this result, we can write first statement is what? P. So negation P or the second statement I have written. Okay, in the second statement also what you are having? It is a conditional statement. Q implies P. Again you can use the same property. What is it? Negation Q or P. So first statement is negation. Next you have to write R. Next you have to write the second statement. Okay. So C means it is commutative. You can use the commutative law. What is it? P or Q or P and Q. That can be written as we can interchange. So therefore, using the commutative law, these two simple statement has to be interchanged. So therefore, P and negation Q. Okay, so you see that here also the symbol is R, here also the symbol is R. If you have same symbol, you can use the associative law. Associative law means you can combine the first and the two. So negation P or P or negation Q. So see that it's a complement law. So P or negation P. It is also commutative also, negation P or P. That is R if it comes, the statement and its negation is tautology. That is true. Only true you will have. Okay, that is the complement law. If the and comes, you have to write false. So here R is there, so you have to write true. So it is T or negation Q. So R means what it is, any one is true, it is true, isn't it? So using the identity law, P or T is equal to T. Okay, so therefore we will get T here. So T means what? It is all the its truth value contains only T. So therefore it is a tautology. So here I have mentioned the complement law. What is the complement law? P or negation P. R comes, it is true. So true or negation Q. Here we are using the identity law. You look at the, what is that complement law? What is that complement law is? You look at P or negation P is logically equivalent to T. And coming to the identity law, P or T is logically equivalent to T. Because R comes, one is true, it is true. So here you are having only one true. So it is true. So therefore it is a tautology. So the same thing, we are moving to the question number 14. Prove the statement, same statement. P implies, Q implies R is logically equivalent to P and Q implies R without using the truth table. So the same result we are going to use. So implies means what you have to write? You have to write the negation of first statement or Q. So you have to consider, this is the second statement. So first statement is P. So negation P or the second one you have to write. So in the bracket also it is a conditional statement. So the same property has to be used. For the first statement here it is Q. So negation Q or R. Okay. Next what you have to do, you look at the symbol, here also R, inside the bracket also R. So you can use the associative law. So I can associate the first and the two. So negation P or negation Q or R. Okay. So can you say what it is? It is nothing but we can use the De Morgan's law. What law? We can use the De Morgan's law. You look at this. Negation P or negation Q can be written as negation of P and Q. Okay. So here it is negation P or Q or negation Q can be written as negation of P and Q or R. You see that first statement negation, in between you are having R, the second statement. So it can be written as the first statement negation or Q. If you have, you can write which one? P implies Q. So therefore P and Q implies R. So we have proved they are logically equivalent without using the truth table. We are using the laws. Okay. And coming to the example 12.19. You see the word using the equivalence property. That means we have to use all the laws of equivalence. We have to prove the result. Okay, we should not use the truth table. So you see that one more result. P if and only if Q is logically equivalent to P implies Q and Q implies P. Okay, you take the result P if and only if Q. So how it will be written? P implies Q and Q implies P. Okay, so P implies Q. So the previous problem we have seen that. So first statement you have to write negation. So negation P or the second statement. Here also the same thing. First statement negation or the second statement. Okay. So here you see the symbol here. Here it is R, here it is AND. Okay, you consider this is a single term. And here you are having R, here you are having AND. So the symbol connective has changed. So therefore, we have to use the distributive law. Take the first one, negation P and the whole thing. So I have written R, Q and the second result. Okay, so I have distributed. And see now here also and here also R. So you can distribute. How to write negation P and negation Q or negation P and P. So in between you are having R. Here also the symbol, you look at this, the connective is and, here you are having R. So we can distribute. So take the first one, Q and negation Q. In between you are having R, Q and P. Okay, so see now here you can use the De Morgan's law. So it is a negation of P or Q. Here it is and, so you have to write the negation of P or Q. Whereas you see that the statement and its negation. So in between you are having and. So it is called complement law. So what is it? It is called the complement law. So for that and is there. So and means you have to use F. Okay. So see now, complement law, P the statement and its negation. Okay, so that is F, and P or negation P is true. Okay, so you here what you are having, negation P and P. So and is there, so you have to use F. Here also Q and negation Q, so it also F. Okay, so see that here or F, if it comes, you see that is P or F. So P or F, if it comes you have to write P. So this is your the statement, and or F means you have to write P. So negation of P or Q. In the same way, if you combine these two, the statement here what you are having, or F. So it depends on the statement. So here you have to come Q and P. You look at this. So which law? Identity law. The statement, that is P or T comes, you have to write T. But the statement or F comes, you have to write the statement. So here this is the statement, compound statement. Or F means the answer is the statement. In between you are having R. In the same way, same thing. What is that? F or the statement. So you have write the answer as the statement. Okay. So see now here what you have to do. In between you are having R. So you can use the commutative law. So this statement will come first or the second one. So again use the De Morgan's law. What is it? Negation P and negation Q. Okay, so this is, if you use the commutative law here, this P will come first. So P and Q. So this is the result we need. So using the equivalence property or using the laws of equivalence, we have proved the two compound statements are logically equivalent. Thank you, students.